Hello, welcome to the video. In this section, we're looking at section 2.3, where we're going to look at postulates and diagrams. So, what the essential question here is, in a diagram, what can be assumed and what needs to be labeled? So, what we have to do now is we when it comes to looking at proofs and formulating a enough information, compile enough information in order to write a form of proof, which we'll do towards the end of this chapter. We have to put on our little like deductive reasoning caps where we have to look at facts, we have to look at accepted properties and stuff like that. So if they show us in a diagram that something is labeled correctly, we can make an assumption that whatever the labeling is, we can say that it is what it is as we move forward. If the the diagram is vague, you can't make assumptions on certain things, and we'll look at different diagrams in order to um, create those conclusions. So to start with, we have a few postulates that um, are with respect to points, lines, and planes. I won't go over them a ton here in the video. I would say please review your notes, or I would say press pause and um, jot them down in your notebooks if you don't have the notes. But these are going to be some of the postulates that we're going to take care of, or at least they're going to ask us to um, state with respect to maybe a certain diagram. So here it says state the postulate issued by the diagram. So for part A, it says if this, it looks like we got two intersecting lines, then we have this, and the only difference is they got that point of intersection. So if you were to go into your postulates, I would say that that is postulate 2.3, because postulate 2.3 says if two lines intersect, then their intersection is exactly 1 point. So if you realize that postulate is written as a conditional statement, it gives you an if portion, which is the hypothesis, then they give you the conclusion. So if two lines intersect, which is right there, if two lines intersect, then it intersects exactly at 1 point, and that 1 point is where they had it was in red. I just drew it. So for the second one in part B, I would say that it looks like if two planes intersect, so if I had two planes intersect, then their intersection is one line. That is postulate 2.7. Here it says use the diagram to write examples of plane to point postulate and the plane line postulate. So let's look at the plane point one. So if I were to read that, um, plane point postulate says a plane contains at least three non-collinear points. So to write something about this, I'm going to look at, looks like plane P. So I can say that plane P, which see if you, that's where plane P is, doesn't have a point, so I can name it that. Plane P has three non-collinear points, and it looks like it's going to be B, A, and C, so I'll just do it in order A, B, and C. And if we looked at plane to line, with respect to that same one, I see that in plane B, you got, I'm just going to choose one, so I could say that points A and B lie on plane P. So you can write it either as line AB like this, or if you look at it, it could be line N, just as because it's the N right there that represents that whole line. Um, line AB or line N lie on plane P, lies on plane P. Because the definition of plane line postulates is if 2 points lie in a plane, then the line contains them uh, lies in the plane. Okay, so that's what it says in the postulate diagram. Um, Here they want you to say sketch a diagram showing line TV intersecting line segment PQ at point W so that TW is congruent to WV. So there's a lot of different ways you can write it. I would suggest, you know, pausing this, doing it yourself, and then see how close or how similar you did it to myself, or you can even look in the book. So I'm just gonna say, all right, so I got a line TV, which is right here. I got a line segment PQ. Go here, P and Q, and it's intersecting at point W. So W is right here, and they're saying that TW is congruent to WV. So to illustrate that they are congruent, remember I use these hash marks, and we talked about that in the first chapter. That's how you can denote line segments are congruent, or from one point to another is congruent. So you got to make sure you had those hash marks there. All right, so here it says, which of the following statements cannot be assumed from the diagram? So the first statement they're asking is, I'm going to switch up the color to kind of, it says points A, B, and F are collinear. Collinear means they all lie on the same line. So A, B, and F. So if you notice, because there is a line that goes through A, B, and F, I can make the assumption that it's collinear because it's all in the same line. So yes, I can make that assumption. For the second statement, it's saying that E, B, and D are collinear. Could they be? Sure, they could be, but because there's no line that goes through E, B, and D, I cannot make that assumption. So the answer would be I cannot, no, I cannot make that assumption. So the next statement is AB, line AB, which is right here, is that perpendicular to line S? Well, if you notice here, they got that 90-degree mark. 90-degree mark means that it's parallel. Because they have that 90-degree mark, yes, I can say, I can assume that those things are parallel. Here it says CD is perpendicular to plane T. This one here does not have the 90-degree mark, so in this case, I cannot assume it right away. There may be some ways that you can prove it. Is it perpendicular? It might possibly be, but I can't assume that. And then finally, the last statement says AF, which is right here, intersects BC at point B. So because they gave lines, they gave line segments, and it shows that it does in fact intersect at point B, yes, I can make that assumption. So that is kind of dissecting a diagram through assumptions. And that is also how we use postulates and diagrams. I hope this helps. Until next time.